So yeah, hi, welcome back. So today we are going to solve this problem, Leetcode 235, which is lowest common ancestor of a binary search tree. So what it states is, given a binary search tree, find the lowest common ancestor node of two given nodes in a BST. So basically we are given two nodes. We have to return back the lowest common ancestor of these two given nodes. So let's go more into depth. So according to definition of LC on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be descendant to of itself. So yeah, this is the given definition of LCA. So now let's understand by taking one example. So yeah, so here let's say we have been given P is equal to 2 and Q is equal to 8. So it's obvious that 6 will be the lowest common ancestor. Okay, yeah, cool. So now it's 2 and 4. So yeah, for these two, I think 2 is the common ancestor. So okay, so we need to include this node also. Okay, that was pretty cool example. So these are the given constraints. So node value can be this, and P is not equal to Q. P and Q will exist in the BST, and the range in the tree is 2, 3. Okay, so this question pretty much I think is like what should be our approach. I am thinking, so can we go with the DF? Let's start with first DFS, so if we know the path for the two, that's what I'm trying to say is, like, if Q is equal to 8, we need to go. So can we store a path from 6 to 8, and can we store a path from root to 2? So since this is a binary search tree, so left one will be the smaller one and right part will be the bigger one, and then we can iterate both of that, like one of the set, and we can try to find like if that number is present in the other set or not. If it is present into the another set, then we can be very pretty obvious that yeah, that is the point which should be taken into the consideration. Also pretty much sure that while iterating to the set, we need to start from the last, because we are starting iterating from the top. So obviously the LCA will be the, like, let's say, like, take example of 7 and 9. So for this one the set will contain 6 8 7, and for 9 it will contain 6 8 9. So if we start from the top, then 6 we will start from the first index, so it will come common for 7 and 9, and we will get output as 6. So we need to obviously start from the end part, and we need to see if that is present into the other. So what we can do is, like, iterating, when we can take a set to reduce the complexity and all those things, when we can take a simple vector and we can store, and the vector part we can start from the iterating from the back side. So that is more of a thought process for this question. So yeah, let's start with coding. I think we, yeah, pretty cool, we can start, and we can, I think that will be the better way. Okay, yeah, let's start. So let's take a set of int sp. Okay, and we need to find tree node star p. So yeah, okay, so let's take tree node star temp is equal to root. It is pretty much obviously given in the question that the p and q exist in the tree. So if they exist in the tree, can P and Q be a null PTR? Let's confirm that thing. So yeah, even if P is null PTR, Q cannot be a null PTR, because P is not equal to Q is very clearly stated. So let's not worry, like, uh, root being the empty. So root will never be empty. That is clear indication from that side. So let's start while temp is not equal to null ptr, and if we will be inserting that value into this st dot insert roots value. Okay, yeah, that's perfect. So we inserted root val as it is stated as well. So if p value is less than okay, let's take equal to first. Equal to if p value is equal to roots value, we need to break out of this loop. Else if p's value, so else if p's value is greater than, okay, let's take, okay, temp val is greater than p's val. P's val. So here we can see that p is 2 and root is temp is 6. So we need to go to temps left. Temp is equal to temps left. Okay, and else we can have like temp is equal to temps right. Okay, so that's pretty much this. Now let's return null ptr, and let's try to iterate it for auto it in st cout it, and let's see. So we got 6. I think we should have gotten 2 also here. So I'm not sure, like we not end up getting that. So as we are inserting roots val, so I think we should have, okay, let's print st dot size, and then I might not be iterating it properly, I believe. So yeah, we are iterating it properly, and this is 2. I'm not getting, like, okay, let's have here val. Let's see how many times this got iterated here. Let's comment it out. Okay, so okay, so I think that this got pretty stuck here. Okay, I got it. What was the issue? We need to push temp value. We are doing it wrong here. Temp, temp, and down it is okay. Yeah. So yeah, I think now we are very much clear that we have inserted these values into this one. Let's try to see here once again, confirm here, and if those numbers are present here or not. Okay, so yeah, 2 and 6, both numbers are present very clearly. We can have it like an ordered set also, so it will reduce the complexity. So yeah, we will go with that one later on. Let's first finish the other part of the problem, which is vector int nums. So now again temp is equal to root. Okay, we will be probably having the same thing what we have written here. So I will be copying it again, and we will be having q here. Other than that, q, and we will be inserting in here. So push back, and again here q val. Okay, now let's once iterate. Okay, now let's once try to iterate nums and see if the values are getting inserted properly for int I plus plus cout nums of I. Perfect. So let's comment this out. Let's try. Okay, yeah, I think it should be Q. Okay. Okay, yeah, pretty cool. So we got 6 to 6, 8. Okay. Now let's for int I is equal to nums dot size minus 1. I is greater than equal to 0. I minus equal to 1. Let's have I minus minus. And if st dot find I, if st dot find nums of I, return nums of I. Or else return minus 1 we can do here. Okay. So, okay. So, okay, that's different issue here. Like, we need to have like the node. We need to return the node, I think. So, which again, okay, so we need to have it like a tree node star. Okay. Okay, let's have it tree node star. Then. Tree node star. Let's insert the this value. Remove this thing. Let's remove this thing. And let's remove this thing. And let's have here also tree node star. And that's it. Let's see. Okay. Okay. Do not find set here star. We will have here like temp and here again we will make it of type. Since the numbers are unique, I don't think that there will be an issue because of that. And I still not find. Okay, we will have to make a map out in comma star and mp of temp val is equal to temp. Perfect. Now if mp dot find of I, okay, here also we need to do mp, and I think so. Yeah, I think that this will make sense. We have got like int tree node star, so we have got like whatever the path were there, and we stored a key corresponding to the node, and like nums for that we iterated, and we are now iterating backward and trying to find that if that nums of I is present. If nums of I is present, then we will return mp of nums of I. Now let's see. Okay, I think here we messed up something. It's just a semicolon. Okay. Okay, is not equal to is not equal to mp dot end. Okay, Try to submit it. Okay, yeah, that's pretty cool. It got accepted. So yeah, we did like good work. Let's try to make it unordered map. Let's see if the time complexity gets reduced. So yeah, it got reduced, but not that significant. Yeah. So that's all from my side. I think this solution works pretty well. So yeah, thank you. Yeah, bye.